Let's go. Given an area of integer, then its element represents the number of pages in the highest book. 4 books हैं, पहले book में 12 पेज, 34 पेज, 67 पेज, 90 पेज and so on. We also have an integer showing the number of students asked to allocate books to each student. एक को उसको book देना है, जिससे each student receives at least one book. The objective is to minimize the number of pages assigned to any student. In other words, out of all possible allocations, find the angle where the student who receives the most pages still has the smallest possible maximum. If it is not possible to allocate books to all students, return minus 1. Here we have to make कहाँ पे कट करें ऐसा कि लेफ्ट साइड सम and right side sum the total is minimum. Since this is sorted order, sorted है क्या? ऐसा तो नहीं लिखा कि sorted है. If we assume it's sorted, what we'll do in that case? क्या किया जाए कि करूं? Let's try.
Maybe I'm an alien. Must be something heaven sent. Payback for the.
Created a strong name, 12 votes, 46, 1, 1, 2, 3, 3. No, it doesn't matter. अगर मैं sorted नहीं भी है तो भी अगर मैं sum का array निकालूं तो it will always be sorted नहीं हाँ number of pages will always be positive ना ठीक है अभी मेरे पास 12 46 113 203 है ना where will I put the two cuts one two बोला तो one cut होगा let's take this दूसरा एग्जांपल लेते हैं इसमें k का वैल्यू होगा let's take another example 34 67 90 102 105 सम मेरे निकालने तो 46 113 203 205 3 to place a student in the cut so that sum is minimum, smallest possible maximum. Hmm. कुछ तो activities related क्या है बढ़िया notifications turn off all है I am thinking we have to create a SAM array which will be sorted and then use by analysis to find out where we will put these. If k is 2 then 1 point where will that break will come so that the sum on the left and on the right sum of these two numbers will be least. And find out this means.
Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So today we will be solving the problem allocate books. Now this is a very famous question. This has been asked in Google a lot of times. This is asked in a lot of coding rounds. Yes, they just tweak this question into some other form, and you can see this question in a lot of coding rounds. So what does this problem state? The problem states you'll be given 4n books, okay, and every book will have certain number of pages. Like the first book over here has 12 pages, the second book has 34, the third book has 67, the fourth book has 90 pages. And you'll be given students. Over here we can see we are given couple of students. Your task will be to allocate these books to couple of students such that the maximum number of pages allocated to a student is minimum. What does that mean? We're going to come to that. So let's assume there are two, like they're given couple of students, right? This is student 1, this is student 2. What is the allocation that you can do? So before doing the allocation, let's look at the conditions that you have to maintain while doing the allocations. First condition states a book will be allocated to one student only. Like if this book has 12 pages, you cannot do this. Hey, first student takes 6 pages, second student takes 6 pages. No, this is not allowed. If you are taking a book and you're allocating it, you have to either allocate 12 to this or either you have to allocate 12 to this. You cannot split it. So that's the first condition that you have to keep in mind while allocating. What's the next condition? Each student must get a minimum of one book. That means you cannot do an allocation where you say, hey, student 2, take 12, 34, 67, 90. And you're saying, student 1, I'm not going to give you any book. That's not allowed. Okay. You must at least allow in contiguous take 12 and 90 should be done in books. So this allotment is not done because 12 and 67 has a 34 in between. Hence, 12 and 67 books are not in contiguous fashion. So this kind of allotment is also not possible. So you have to just make sure that these three conditions are kept while you're allocating the books. So you've understood how to allocate by keeping these conditions. Now I'll talk about this condition, which is our question. So once you've understood the condition, you're going to take 34, 67, 90. This is one of the possible allocations that you can do. What is the other possible allocation that you can do? You can definitely try this allocation. 12, 34. You're saying student 1, you're going to take 12 and 34. And I'm going to say student 2, you're going to take 67 and a 19. That's one more possible allocation that I can do. What is the other possible allocation I can? I can say student 1, you're going to take 12, 34, 67. And I'm going to say student 2, you take something as 19. Okay. So these are the three possible allocations that I can do if I keep these conditions in my mind. Rather. So over here, can I say that? And can I say the student 2 is getting maximum allocation? In this case is 191 because student 1 gets 12 pages, 91 pages. So if I look at this allocation, the plus 9, obviously, if I check and the maximum amount is allocated is minimum. Which of the condition has maximum pages? This is maximum. And out of these, which allocation has minimal? I can say this is my answer, which has minimal. 113 is minimal. Hence, this is the allocation that I require. Yes. And you need to print this 113, the maximums, minimum. You have to print this. That is the question. You have to allocate the books in such a way that the maximum number of pages allocated is as small as possible. So I hope you have understood the question. Now, what is the first solution that comes to your mind? It's generally recursion that comes to your brain, isn't it? Basically, you're going to try to partition, whether you'll partition here or whether you'll partition here or whether you'll partition here. Basically, you're thinking of a recursive solution where you'll try to partition. But again, whenever you try recursion, the solutions are generally exponential in nature. And if you try writing a recursive solution to it, you'll get an exponential complexity. And even if you apply dynamic programming to it, you will end up getting a big of n square solution. I'll not be discussing this over here because this is not the most optimal solution. And even if this question is asked to you in an interview, I'll recommend don't tell the solution because it's going to kill a lot of time. Don't even tell the solution. Directly jump to the binary search because explaining the binary search solution is going to take some time in the interview. So don't tell him this recursion and then a dynamic programming, then n square because it's going to kill your time. And after that, you will not have a time to optimize this further. So directly if this question is asked to you in an interview, tell them the binary search solution. Okay. So before moving on to the next part of the video, let me tell you about the sponsors of this. So it definitely. What can be the minimal answer? If I ask you, what is the minimal answer possible, right? And if I ask you, what is the maximal answer possible? If I ask you that, what's the minimal answer possible? And what is the maximum answer possible to this question? And then I can say, this is going to be my search space. Okay, let's now think in terms of all the test cases. Can I say, if I take a test case like this, where the array is like 12, 12, 12, 12, okay, and the number of students is 4. Now, what will be the answer of allocation? Can I say I'll be allocating like 12, 12, 12, 12. So everyone's summation of pages will actually be 12, 12, 12, 12. So the maximum of them is actually 12, and that's the minimal possible. So can I say the minimal, whatever the answer at minimum can be the minimal value of this. Hence, at the worst case, the minimal answer can be 12. It cannot go beyond that. I hope you've understood that, right? Now, what will be the highest answer? Let's figure that out. Now, can I say the highest answer? If I take an example of array to be, let's imagine it's 10, 20, and 30, and I'm giving you the number of student as 1. What will be the highest answer? You're going to allocate everything to the student. There's no other option. So that's basically 10, 20, 30. And if you sum them up, you'll get 60. So can I say, at the worst case, the maximum answer that a combination generate is the summation of all these guys. If I just what will be one thing between 12 and between 203. So I have defined my search space. Now I want to think of binary search. Let's see if we can implement binary search on this. So the answer will definitely lie between 12 and 203. So let's assume this to be low. Let's assume this to be high. Okay. So I have made sure that this is low and this is high. What will be the middle? Middle will be 107. 12 plus 203 divided by 2 will definitely give you 107. So that's your middle. Okay, so figure out the middle. Now what you'll try to do is you'll take these pages and try to allocate to two students such that you do not end up allocating more than 107 pages to anyone, because you want 107 to be your answer, right? So what you'll do is let's take the student 107 to be more than 107 such that you do not end up allocating more than 107 pages to anyone, because you want 107 to be your answer, right? So what you'll do is let's take the student 1. You say 12. Okay, give it to student 1. It still has not exceeded 107. You take 34, give it to student 1. It still has not exceeded 107. You take 67, but can you give it to student 1? Because if you add 67, student 1 will actually have 113 pages, but you cannot exceed 107. Hence, you will not allocate this 67 to student 1. Rather, you will allocate it to student 2. So take this 67 and allocate it to student 2. Now, can you allocate this 90 to student 2? Can you? Because the moment you add 90, it exceeds 107. So you're not allowed to allocate 90. What do? You'll take this 90 and allocate it to student 3. Yes, you'll allocate it to student 3. So I was able to allocate all the books, but I figured out that I actually, by keeping a maximum barrier of 107, I ended up allocating books to 3 students. But the question clearly stated, I only have 2 students. So you cannot allocate books to 2 students by keeping a barrier of 107. So you need to increase the barrier. Obviously, by keeping 107 as a barrier, you could not allocate. So by keeping 106, by keeping 100, by keeping 13, you will also not be able to. So can I say this portion can never have my answer, and my answer will lie somewhere between 108 to 203. This is why binary search can be implemented, because I know if by keeping a certain barrier, I could not, the entire left side automatically gets eliminated. Hence, we will do this. The search space is now this. Let's figure out the middle. So if you figure out the middle, you'll get 108 plus 203 divided by half. That's nothing but 155. So you get the middle as 155. Let's try to allocate. So the student 1 takes this 12. The student 2 takes this 34. The student 3, 1. Hence, you cannot take this 90. Hence, you will take this and say student 2 to take this 90. So I can see by keeping a maximum barrier of 155, I could allocate to couple of students. Yes, I could allocate to couple of students. And if I can allocate to couple of students, can I say 155 can be one of my possible answers? Yes, I can definitely say 155 is one of my possible answers. So what is the question stating? You need to figure out the minimal. So which portion will get eliminated? 156 will also give you, 157 will also give you, but you need it to be minimal. Hence, the search space, the right search space will decrease. And now you'll do a binary search from 108 to 154. I hope you're getting it. So now you have reduced your search space to 108 and 154. So the middle this time will be 131. So again, try to distribute books by keeping this barrier of 131. Take 12, distribute to person 1, cross table 2. Hence, related, this will be 100. Then it will get the 34 by keeping 100 barrier. So I'll write it over here, and the search space will reduce to this much. And if you try to keep this as a barrier, I was able to. Hence, my answer gets reduced to 113. My answer is getting reduced. So obviously, I'll not be requiring this. So the right half will be eliminated. So let's eliminate period and try to allocate books. So the student 1 will take 12, 2 will take 6. Again, 108, 2 is standing at 113. So now the middle of this and this is nothing but 111. So let's try to keep this as a barrier, and let's try. Student 1 will take 12, 34. Yes, that's not possible. So this left half will get eliminated, and the search space will be trimmed down to 112 to 112. Yes. So your low will be 112. Yeah. So if I try to allocate 34, 3 will take 9. So this guy will go ahead, and the low will become 113. What happens in binary search, right? So over here we can see this is the new search space, and what I can see is the search space, the low is crossing high, and that's when the binary search ends. So what I can say is, if low has crossed high, that means from 113, 114, these barriers were achieved. You can keep a maximum allocation of these 111. The minimal of this allocation, the minimal is 113. 13. That's your answer. This is how you're going to do a binary search to figure out the answer. Now, we know we have to write a binary search. So we know low was nothing but the minimal in the array, and high was nothing but the sum of the array that we took. And initially, let's keep resultant, which was the answer that we're storing as -1. Now, we have one thing, the binary search, this is the condition. Now, in starting, what do we write? We write something as mid equal to low plus high by 2. That's very obvious. This is what I write, low plus high by 2. Now, what were you checking? Can this be possible? Like, can the allocation by is if the allocation is possible? Yes. If the allocation is possible by keeping the barrier of mid, if by keeping the barrier of mid, if the allocation is possible, what does that mean? That means I'm saying this mid can be my answer. Hence, I'll update res by mid and I'll reduce the right half. Yes, I'll come to that because I want to make it minimal. So high will become mid -1. I will become mid -1. But if this allocation is not possible, then what will happen? Then I will have to reduce the left half because keeping a smaller barrier was not. not possible. I have to increase the base. The bar check in array tells you if it is possible to allocate these books among these students by keeping a barrier of this. It returns true if it is, and it returns false if it is not possible. So what we will do is we will take allocated students. What is the initial student? Because initially we start with one students. So initially the allocated student is one. As of now we have just started with one student. And what I can say is the number of pages that I've allocated to the students is as of now zero, because currently we have first student and I haven't allocated it. I'll take 12, then I'll allocate it. Then I'll take 34, then I'll allocate it. I'll take 67, then I'll allocate it. But as of now I haven't. So in order to take 12, 34, I will have to iterate from from 0 till n, correct? And I will have to go like this. What do I need to check? I just need to check if first of all, just think of this condition. If this barrier is somewhere like 10, okay? If the barrier is 10, will you be able to allocate 12? Not possible. Even if you take the second student or the third student, and in order to by chance your individual array element goes beyond barrier, that means that book cannot be allocated. Hence, I will say by keeping this barrier, I will not be able to allocate, hence you'll return false. But what if if it is inside the variable. So pages, when you say to a little of 2 and 6% because it was about allocation is to the right as keeping a smaller variable plus if you are given a value, how do you check an array if an array is and because until if you cannot report if 0 plus 12, if you take a variable, let's say 110, it doesn't crosses. If it crosses, we're going to do something. But if it doesn't crosses, we are going to add it to our student. Yes. Let's say student end. What about 100? So that's plus equal to 1. You cannot go to 1. If this allocate 2, assume this 2k is greater than 2, then I can say I was not able to allocate. Comes over here, right? This portion will, if it is possible, loop. It's a big of n. So the binary search takes logarithmic of n, right? And this is the is possible function. So if you remember the structure of the code, it was a binary search. Inside that, this is the is possible function that you called. What is this is possible function taking? Big of n. So I can say the complexity is log n into big of n. That's the time complexity. Are we using any external space? No. Hence the space complexity is big of 1 for this particular solution. So guys, this is my first whiteboard video and you can see I'm shooting at 3 o'clock in the night. Go of 1 for this particular solution. So guys, this is my first whiteboard video and you can see I'm shooting at 3 o'clock in the night. So please drop in a comment. Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So we will be continuing with our binary search playlist as a part of the Strivers A to Z DSA course. In case you're for the first time here, there's a link in the description. The biggest number 49, isn't it? So I'll be like, the highest possible answer will be some. So what I'll say is, okay, you please hold this. In this, I was adding in that student. Now I've moved to the next student and I've given him that. That's it. Done. At the end of the day, you just need to return how many students did you take. So just return the number of students. So this will return the number of students given this particular condition, and then you can simply check if that's equivalent to your number of students. You say, fine, this is my answer. I'm done this. Got it? So what will be the time complexity? Can I say that the time complexity is we go off. I'm running the loop from sum to max. So sum minus max plus 1 is the length of the linear search at the worst case. And I'm also running a function, and the function is running for a big O of n. So that's a big O of n. Obviously, the interviewer will not be happy with this. I'll ask you to optimize. This is when we will move to binary search. Okay, so binary search. Now the question is, hey Striver, when is it not possible? I'm having 5 books. It's possible to allocate to 4 students, right? When is it not possible? It's very simple. If the number of students were 6 and I just had 5 books, then each of these students would not have got at least 1 book. Because it's not possible. I just have 5 books. I cannot give it to each of them. Thereby, in any case, when the number of students is greater than the number of books, the answer is not possible. So somewhere I have solved a mini part of the question. But still, the majority is still left. So how do I solve that? Now, I know one thing for sure. Whenever we have something like max of min or min of max, binary search will be applied. But I'll not go straight away to binary search. I'll start thinking. Okay, what's the standard like brute force? The brute force is like, okay, I'll take maybe 1 can be my answer and I'll try it. Maybe 2 can be my answer, I'll try it. Maybe 3 can be my answer, I'll try it. 4 can be my answer, I'll try. 5 can be my answer, I'll try. I'll keep on trying. The first number would say that yes, I am your answer. Yes, I am your answer. You stop then and there. You stop then and there, right? Because the question is stating to find out the minimum. But I'm asking you a question. Do you start from 1 and then go to 2, then go to 3? Do you need to start from 1? No, you don't need to. Why? Because if you take 1 as your answer, like you're saying 1 is the maximum pages someone has. 1 is the maximum pages someone has. Dude, if someone has just 1 maximum pages, he cannot even hold a book. He cannot even hold a book because even to hold 1 book, someone needs 24 pages. Even to hold 1 book, someone needs 24 pages. Something I've got for sure is, at least I need 24. At least I need 20, right? But if I take 24, does it make sense? Because even if I take 24, I'm saying the maximum someone is holding is 24. Then no one will be able to hold 26, no one will be able to hold 20, like all these numbers. So technically, where should you start from? You should start from the biggest number 49. You should start from the biggest number 49, isn't it? So I'll be like, okay, maybe let's start from 49 because if I take 49, at least everyone can hold 1 book because I'm looking for maximum number of pages assigned to a student. What I'm saying is take 49. That's the maximum someone can be assigned to. Perfect. Start thinking in this way because if you just straight away say binary search, it will not help you to learn problem solving. This is how you think of problem solving. Got it? So let's try to solve this particular question. First thing that I'll do is I'll try to solve it for this condition where you have to return minus what not possible. It's right. Would not have got at least 1 book because it's not possible. I just have 5 books. I cannot give it to each of them. This is not possible. So somewhere I have solved a mini part. Whenever we have something like max of min or min of max, binary search will be applied. But I'll not go straight away to binary search. I'll start thinking. Okay, what's the standard like brute force? The brute force is like, okay, I'll try. Can be my answer, I'll try. 3 my answer and I'll try. Maybe 2 can be my answer, I'll try. Maybe 3 can be my answer, I'll try. 4 can be my answer, I'll try. 5 can be my answer, I'll try. I'll keep on trying. The first number would say that yes,
I am your answer. Yes, I am your answer. You stop then and there. You stop then and there, right? Because the question is stating to find out the minimum. But I'm asking you a question. Do you start from 1 and then go to 2, then go to 3? Do you need to start from 1? No, you don't need to. Why? Because if you take 1 as your answer, like you're saying 1 is the maximum pages someone has, 1 is the maximum pages someone has. Dude, if someone has just 1 maximum pages, he cannot even hold a book. He cannot even hold a book because even to hold 1 book, someone needs 24 pages. Even to hold 1 book, someone needs 24 pages. Something I've got for sure is, at least I need 24. At least I need 20, right? But if I take 24, does it make sense? Because even if I take 24, I'm saying the maximum someone is holding is 24. Then no one will be able to hold 26, no one will be able to hold 20, like all these numbers. So technically, where should you start from? You should start from the biggest number, 49. You should start from the biggest number, 49, isn't it? So I'll be like, okay, maybe let's start from 49 because if I take 49, at least everyone can hold 1 book because I'm looking for maximum number of pages assigned to a student. What I'm saying is take 49. That's the maximum someone can be assigned to. Perfect. Start thinking in this way because if you just straight away say binary search, it will not help you to learn problem solving. This is how you think of problem solving. Got it? So I'm saying maybe 49. I'm not sure. Okay. Let's go with student 1. He's at 25. He says I can take 25 because I'm allowed to take 49 because I'm thinking at the maximum as 49. Okay. Can I take 46? If I add 46, I'll exceed my maximum. I don't want to exceed. Thereby, the student 2 will take 46. Can he take 28? He cannot because it will exceed. The student 3 will take 28. Can he take 49? No. So 49 will go to student 4. And then, can he take 24? No. So 24 will go to student 5. But what was the question stating? To make sure that the books are allocated to 4 students. So what I observed was, if I'm taking 49, which is a very small number, hence I exceeded the number of students because the number was so small that I ended up having more students, but I cannot afford that. So what I have to make sure is that to somewhere maybe fit it in 20, like fit it in 4 students. Thereby, I'll try to increase this. Then I'll try to increase this. Then I'll try to increase this. Then I'll try to increase this. I'll go ahead and increasing this. And there will be a point. Haha, where am I? Just a second. Yeah. There will be a point where I'll reach 70. Because I'll show you for 70 what happens. For 70, what will happen is, let me erase this as well. For 70, again I'm at 25. It takes 25. But the moment it tries to take 46, it is actually 71. So it is exceeding 70, so he cannot. At 2, it will take 46. Can he take 28? Because if he tries to take 28, that will exceed 70. So he cannot. At 3, he will take 28. Can he take 49? No, it will exceed. So the student 4 will take 49. And the student 5 will again take 24. Again with 70 also, I'm taking 5 students. Hence, not possible. Next, the moment you increase it to 71, see what will happen. Too many color changes. Anyways, student 1 says, I can take 25. And he says, I can also take 46 because the highest permissible number of pages is 71. And that's possible. So I can take it. I'm like, okay, if you can take it, that's fine. Can you take 28? He says, no, I'll exceed. Okay. Maybe the second guy will take 20. Yes, he can. Can he take 49? I'm like, no, that will exceed. Okay, 3. Can you take 49? He says, yes. Can you take 24? He says, no, I'm exceeding. Give it to the next guy. He says, okay. And you are done with, you have distributed all of them when it was 71. With 71, you have made sure that it is distributed among 4. And thereby, your answer is 71. So what I did was, I started with the maximum value because that's what the thought process is. I have to make sure that everyone can take at least 1 book. That's the thought process. That is why I started from 49. Because if I would have taken 24, these books, like, they could not have gone to anyone, right? That's why I started with 49. I kept on increasing. And this is how I'll go. But if I ask you, till what can be the maximum possible answer? Because what if I don't get it? I just can't keep on going, right? What can be the maximum possible answer for any of the case? Just try to think of the range. What can be the maximum possible answer? What if I ask you what is the worst possible scenario? That's when you're given 1. In that case, what will you do? You'll be like, all the books will go to 1 because we don't have anyone and we have to allocate all the books. In that case, can I say it'll be the summation of the array which will be your answer? Because there's only one possible configuration, that is, goes to the student 1. Hence, your answer will always lie between high to summation of the array. Got it? I kind of figured out the range. Now I will be doing a linear search. So let's quickly write down the linear search because you've understood the thought process, right? So can I say that the lowest possible answer will be the max of the array? Indeed. And the highest possible answer will be, I'm not writing binary search, I'm writing linear search. The highest possible answer will be the summation of the array. I can definitely say that, right? And the maximum pages allowed will be from low to high because first I'll start with 49 in this case and then 50, 51, right? And can I say I'll write a function which counts the number of students, I'll pass on the array which contains the pages. I'll say that this is the maximum pages allowed, and I'll also tell him that these are the, now like you don't need to send the number of students here. You can say array and the number of pages. And can I say if I was able to allocate to exactly m students, my job is done. This is my answer. Written pages. Quite simple. this is a linear search. I just need to make sure that I write this particular. I've written the linear search, but somehow you have to write this particular function, which computes the number of students when you are sending the maximum pages allowed. So what I'll do is I'll go across and say function, please take an array, and this is the maximum pages allowed. Please remember that this is the maximum someone can hold. I'm thinking that this can be the answer or not. So what I'll say is, okay, initially I'm at the student one, and the pages that the student has, maybe I can see pages on that student is as of now 0. So I'm saying student one is holding 0. Then can I take maximum? Take it. We don't need to include like the next restart to give it to the day answer. I'm done in this particular condition, and you can simply check if that's equivalent to your number of students. You say fine, this is my answer. I'm done in this. Got it? So what will be the time complexity? Can I say that the time plus 1 of n? That's a big of n. Obviously, the interviewer will not be happy with this. I'll ask you to optimize. This is when we will move to binary search. Okay, so binary search. Now the question is, hey Striver, how do we think of binary search? First reason is linear search did not work out. So the next solution is definitely binary search. And the second reason is maximum minimum. Whenever the question is revolving around max, min, min, max, find the min, you know there's a potential to apply binary search. These are the two reasons, like because that was not accepted, and you see max, min, you will tilt towards binary search. Got it? So we know one thing, the answer will be from maximum, which is 49 in this case, and the summation, which is basically 172. So I know that the answer will be from 49 to 172. If I ask you a very simple question, how many students were required if you kept a barrier of 79? If you remember the linear search, the number of students required was 5. If I keep a barrier of 172, how many students will be required? If I just take one student, I'll be able to give everyone, like all the books to that one student. So if I take a barrier of 172, one student will do my job. How many students do I have? I have 4 students. Thereby the answer will lie somewhere in between, which was 71 in this case. And the number of students were required was 4. The number of students required were 4 in this case. So maybe a binary search will help. Why? Because to the right of it, the number of students will be like 1, 2, 3. Because the number is larger. The number is larger. So the number of students will be lesser and lesser. And over here, since the number, like the barrier, is very small, you cannot distribute a lot of books. Thereby the number of students required will be larger. So maybe I can do an elimination based on this factor. So what I'll do is, I'll try to binary search playlist. No worries. Just focus on this, that the low ended here. That's why the low is the answer. Otherwise, you can also. Also carry an answer variable and store it. Full max element STL and the accumulated function, which gets me the sum, and then
Hello guys. Hello, welcome. It was a good question. A little bit hard for me. I will get it.